Good day, ladies and gentlemen. I welcome you all to Shito's Mathematics Coaching Program. Before the commencement of today's lecture, I urge all of you to at least subscribe to my YouTube channel, hit on the bell and the subscribe button in order to get the notifications for my videos anytime I drop them. So I will give you some seconds to do that, so then we go further. So as I said earlier, I said parametric differentiation, so that is what we are going to look at today. So we are looking into what we mean by parametric differentiation, so that is what we want to do. So now, in this parametric differentiation, so is another part of differentiation, you understand? So now, which involves three variables. That is, you can have, let's say we have variable x, variable y, and t. Are you getting it? I want you to follow me very well and listen attentively in order to get what I'm trying to explain at the board here. So now, in this parametric differentiation, you are to be given two variables, now the three variables rather. So we have variable x, variable y, and variable t. So, but one of these, let's say x is given or is expressed as what? As this variable t, and also y expressed as what? As this variable t. You can see that two of the variables are expressed as a function of the what? Of the third variable, which is t. Are you getting what I'm saying now? So now, since we have this, so this t, we call it what? We call it parameter. So our t, that is this variable t, is called what? Is called parameter. I don't know, maybe you are getting what I'm saying now. So you'll be given two kinds of functions like x and y, then another third what we call variable t. So the x and y will now be expressed in terms of what? In terms of this third variable, which is t. I don't know, maybe I get what I'm saying now. So we are now to get what? To get, now sort of find d z, or let me say d y over what? Over d the x. Understand? Dy over dx. So to get dy over dx, we now have the formula dy over dt divided by dx over what? Over dt. So now that's the formula we mostly use, understand, in getting the differential coefficient of this one, of this y. I don't know, maybe I get what I'm saying now. So that is the formula. So now, let's say we are given this particular question to solve. That is, if x equals to at squared, y equals to 2at, then find dy dx. Are you getting what I'm saying now? See the question. If x equals to 80 squared and y equals to what? 280, then find dy dx. So here, who can tell me the parameter here? So solution here, the parameter is what? Is t, because we are given x expressed in terms of t, y also expressed in terms of what? In terms of t, and it has us to find dy dx. So now, which means t is what? Is our parameter. So now, how do we get this? You know, dy dx equals to dy over dt divided by dx over what? Over dt. So that is the formula. So now from here, before you can do that, so you try to look for this, then you look for this, So now to get dy dt, so from y, y equals 280. So from here, what is your differential coefficient of what? Differential coefficient of y here is what? Is dy dt will be equals to 2a. That is the differential coefficient here of this. Also, we take x equals to what? X equals to at squared. So now, what is the differential coefficient of x here? We have what? We have dx divided by d what? dt. So what do we have? We have 2, that is this 2 will come down, multiplied by a t. 2 minus 1, we have what? We have t. So therefore, we have this and we have that. I don't know, maybe I get what I'm saying now. So now, given this one out, so you now conclude that your dy over dt, no, dy over dx, what they ask you to get, that is dy over what? Over dx, so will now be equals to dy over dt. So what is dy over dt? Dy over dt is what? Let me write it again. Dy over dt divided by dx over what? Over dt. So now from here, so what's the next thing to do? We have dy over dx to be equals to dy over dt is what? Is 2a, then divided by dx over dt. So what is dx over dt? Is what? 2at. Are you getting it now? So now, how are you going to do this one? So we have what? We have dy over dx to be equals to, you can try to express or to write this one in form of this, 2a over what? 2at. I guess what I'm doing here. So now reduce this one to the lowest term. So what do you have? You have what? You have 2, we cancel 2 here, a we cancel here. So what do you have left? You have 1 over what? 1 over t. Therefore, automatically, our differential coefficients of the function y will give us 1 over what? 1 over t. So which is the final solution to this. I'm getting it now. So let me come again and try to recap, as it will give you the recap of all I just said. So if you are talking about parametric differentiation, so what you have to know is that you'll be given 3 variables, which 2 of the variables will be expressed in terms of the third variable. So as we have here, like s here, we have y, then we have t. So s is expressed in terms of t, y is also expressed in terms of t, which means t is our parameter here. Understand? So now look at this formula, because this is the formula we are going to use. So you look for the differential coefficient of what? Of x, that is dy over dt. Then you look also for the differential coefficient of x, that is ds over dt. So this is the formula. So now from here, you find it here, you find it here, then you substitute inside the formula we have as we did here, then you have your final answer. So that is that about parametric differentiation. So you need to know how to differentiate from these basic rules. So it is very, very important. So that is that about today's lecture. So if you have any questions to ask, or there's something here that you are confused about, so don't hesitate to ask me a question. So I wish you best of luck in your endeavors. So thanks.